Today we're going to talk about mixed number addition and subtraction. We'll start with a very basic addition problem. 1½ plus 2/3. To do this, we need to have two identical rectangles to represent my 1½ and one rectangle to represent my 2/3. I'll label this one 1½ and I'll label this one 2/3. I'm then going to break apart my 1½ with these vertical partitions, break it into halves. I'm going to shade in one whole and my 1/2. Then I need to take horizontal partitions and break apart my second fraction into thirds and shade in two of them. After I shade in these two, I need to flip-flop my partitions. So whatever I did to one, I need to do to the other. If I broke this into thirds, I need to break this into thirds over here. And when I do this, it creates the common denominator or common unit of sixths. I'll break this one in half, again doing the opposite. And now I have my common denominator of sixths. 1, 2, 3, 4, 5, 6. There are 6 sixths over here, and there are 3 more sixths over here. Together that makes 9 sixths. Over here I have 4 sixths. 1, 2, 3, 4. Okay? I'm going to add these together. So now I have a common unit, sixths. I can add 9 plus 4, and I get my answer of 13 sixths. I then need to take and convert this improper fraction, like this guy up here, into a mixed number. 6 goes into 13 twice, and there's 1 left over, 1/6. Okay, we can actually see that answer, 2 wholes and 1/6, if we look at our visual model. We have 1, 2, 3, 4 sixths over here. There's only 3 vacant spots over here to fill up. 1, 2, 3. Now we have 2 wholes, and here's our 1/6 left over. Okay? So addition with mixed numbers is pretty straightforward. Not a lot different. Just don't forget about the whole numbers that we have on the left-hand side. We've been looking at just using common denominators to avoid doing all of the work with the visual model. So if I do another quick problem, 2 3/4 plus 4 5/6, I could go ahead and just line these up the standard way and create my common denominator of twelfths. Whatever I do to the bottom, I do to the top to make an equivalent fraction. 5 times 2 is 10, and times 3 and times 3 is 9. Now you see here we have 19 twelfths, which I can then simplify, make it into a mixed number from this improper fraction. 12 goes into 19 once, and there's 7 left over. I need to take this and add it to my original whole numbers in the problem. So it's 4, 5, 6, 7, and 7/12. Let's take a look at some subtraction problems. Our first problem, again, I'll start with a very basic one, 1½ minus 2/3 this time. Okay? To do our visual model, again, we'll need 2 of these rectangles to represent our mixed number and 1 to represent our other proper fraction in the problem. 1½ minus, this time, 2/3. All right, so I'm going to break this just like I did on my first example for addition into halves vertically and then into thirds horizontally. I need to shade in my parts to show I have 1 whole and a half, and over here I have 2/3. thirds. All right, we're going to go ahead and flip-flop our partitions now, so I'll cut this into thirds over here. And I'll cut this into halves over here. And we just made our common units again, just like our first problem of sixths. Okay, 1/2, same, 1.5, excuse me, is still 9/6, and 2/3 is still 4/6. And this time I'm going to subtract instead. So 9 minus 4, 5/6 is our final answer. Okay, another way to show that physically on the model itself, we started over here with 1.5 or 9/6, and we're removing or taking away 4 of those sixths. I can take away 1, 2, 3, 4, and then you see I'm left with these 5/6. 1, 2, 3, 4, 5 out of 6. All right? This visual model works well when we have a small mixed number minus a fraction like we see here. However, when we go into larger mixed numbers, the model isn't as efficient. And in fact, it might be more laborsome than helpful. So let's look at another picture, or another problem rather, where we wouldn't want to use the picture, we would want to just use the least common denominator. 8 and 7/12 minus 3 and 3/4. Again, this time I'm electing not to use the rectangular fraction model, just to find that common denominator of 12 and 4. Oftentimes, the least common denominator happens to be one of the denominators we have in our problem. So I'm going to just leave that 12 alone up here and just change my 4 to a 12. Times 3, I have 9/12. This is where we run into a problem with subtraction. I cannot do 7 minus 9. 7 minus 9 is not 2. Please don't get into the habit of subtracting up. So we're going to go ahead and borrow or unbundle from our neighbor like we would do in any other subtraction problem where we cannot subtract. Okay? We're going to borrow or unbundle this 8. This 8 now becomes a 7. Every time I unbundle or borrow from this guy, he becomes, over here, in this case, 12/12, because our whole in this problem are twelfths. If I borrow one whole, I need to add 12/12 to my existing fraction of 7/12. 7/12 plus 12/12 gives me my 19/12. Okay? Now I can subtract. All of this is now gone, except for our 7. Okay? Now we just renamed 8 and 7/12 into 7 and 19/12. 19 minus 9 is 10 of those twelfths. 7 minus 3 is 4. And then we just got to simplify our answer here. We see 10 and 12 still share a common factor of 2. So our final answer will be 4 and 5/6. Again, would not have been efficient to draw out 9 rectangles, 8 of them being wholes, and then trying to break them all into twelfths. Would not be the most efficient strategy. So we want to focus on trying to find that least common denominator, also called the least common multiple. And we know in my class we've called it the least common denominator, unit, multiple, or peanut.